recording. Okay, so now I'm recording. So to access WinSCP, please find WinSCP on your system. And with WinSCP, you're going to connect to carbon.ru.ac.za. Okay. And your username must have no capitals in. And then the password I sent you. And then when you log in, you'll get some messages, which is fine. But once the messages are gone, you'll be able to see WinSCP. And on the left-hand side with WinSCP is your local computer. On the right-hand side is a cluster. And you will have nothing on the cluster to start off with. Unlike me, I've done a lot of work on the cluster. So I've got a lot of things. But to copy, you just drag across. So there's WinSCP. WinSCP does allow you to have a terminal, but I prefer PuTTY. So with PuTTY, what you've got to do is you've got to search for the PuTTY application. There it is, the PuTTY desktop application. Don't PuTTY Gen or the installer, just make sure it's PuTTY, the desktop app. Now to connect to PuTTY, we again need to go to carbon.ru.ac.za. But this time you don't type your username in straight away. You've got to connect to Carbon first. So when you go open, you may get some messages first before you go here. Just clear them and say yes to them. But when you get to this window, now you can type in your username with no capital letters. So I'm going to type in my username, and then it will request my password. Notice it won't show anything as I type in my password. So I am typing now, but you can't see any change as I type in. And now I have logged in onto the cluster. So can you see the two windows here? WinSCP is for copying stuff to and from the cluster. This PuTTY here is to actually command the cluster. Okay. To give you an idea of the command that we can do with the cluster, how we can do it, is we can do something like, I can type qstat. This is a fantastic command to type into the cluster because it tells you everyone who is currently using the cluster at the moment. When you press enter, I can see that Bakri and James are both using the cluster at the moment. I'm logged in, but I'm not using it yet. I haven't asked the cluster to do anything. So please, there are some powerful things that we can use. And I'll tell you some of the commands as we come to them. But qstat really is a command that tells me how to use the cluster. And of course, at the end of it, you can just close the window, or you can type exit. If you type exit, that's a command that says you no longer want access to the cluster, and PuTTY will disappear. Would you like me to run through either of that again? Okay. Yes, yes. Do you have a question? You're right.
Oh,
okay.
All right.
Okay, fantastic. So, right, that's two things. So please make sure by today you can do that, and let me know whether you can or can't. Okay, and we'll try and troubleshoot by email whether you can. Okay, the final tool that I want to look at today, I'm going to need to just have a look. So just, if I can go to my email, I have emailed myself the license, and here it is. Here's the license for Marvin Sketch. So I just need to download it. I'm going to save a file to my downloads, which is fine. And then I'm going to install Marvin Sketch. And hopefully Marvin Sketch will install nicely on my system. Okay. Okay, here we go. Smart Screen didn't like it, but trust me, Marvin Sketch is it is a trusted program. It's not going to cause problems on your computer. You need to accept the terms. Standard is fine. And I'm just installing Marvin Sketch over here. We're done. Okay, so I've now got Marvin installed. And when I do a search, let's just do search for Marvin Sketch. There we go. So I can now run Marvin Sketch. Okay. Okay, so it says, oops, you don't seem to have a valid license. If it comes up with that, you can go install licenses. And you can just browse. I'm just browsing to the one that I've got. Recent, let's just see, desktop. I need downloads. Downloads. There we go. Just find it on your computer, that license. There it is. And open. And we've got that, and install it. Okay. And then you have then access to Marvin. Okay. And there should be a way to install the license if you've got it straight open. I think license, you go help licenses, and you will be able to install a license file from help licenses. So if it comes up like this, you'll be able to install a license directly from there. Okay. So we have a structure that we need to draw. And so I'm going to just try and start one of the structures that we had in the continuous assessment task. I've got it up on another screen here. So I'm going to see if I can draw it. And that was molecule number 1. It's 5-rect ligand. And I'm going to start with these templates here. It helps sometimes make it work. And let's just see if I can, there we go. So I've got the basic structure of it together. I may need to draw with a double bond. Yes, there we go. So that works nicely. And you'll notice that I haven't quite drawn things correctly. So I've done everything with carbons. And this works quite nicely. There we go. So I've got that, and let's just draw the final thing here. There we go. So here we go. This is the structure that we had, except that I need to change some atoms. This atom here is an oxygen. We have some nitrogens. That's a nitrogen. And that's a nitrogen. Okay. And this is a nitrogen over here. Okay. So that is one of the structures that we had available. Please, it's very important when you draw structures to make sure that all hydrogens are present. And if you look at the notes, I've told you that you've got to look at the structure tool, and you've got to add and make sure that you've got explicit hydrogens. Okay. Now, in this, I have got all hydrogens present. So I'm absolutely happy that all atoms are there. This is very important. If we try and do a calculation on the electrons in a molecule, and you've forgotten to put the hydrogens in, if we had not put the hydrogens in, the calculation on the electrons would be missing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 electrons. So the calculation would not be correct. So a lot of the calculations we can do to clean up structures involve calculating the electrons, calculations on the electrons. And without the correct atoms present, we cannot do that. So please always make sure that unless you've got a very good reason for hiding the hydrogens, that those hydrogens are definitely present in your molecule. Okay. And then, of course, in the structure, we can clean in 3 dimensions. And so what you have now is a 3-dimensional structure that we have now available to use. Okay. So there's a lot I can do with the structure now that is in 3 dimensions. Firstly, I could save it. That's interesting. Well, maybe let's just do that. Let's save it. I'm going to file save as, and I think this was 5rec. Don't save it as a Marvin document. Save it as something that's a little bit easier to work with. And I'd really recommend there is, if you can save it as a mol2, that is a good version. There are many options to save. I can see there's mol there, SD. Let's see if we've got an option for mol2. Yes, there we go. See, if you go down far enough, there's a mol2. And I'm going to call it, so mol2 is a really useful file, and I'm going to call this, this was 5REC with mol2. Okay, that's the first thing we can do. The other things we can do on the calculations, we could do isomers. We could search for tautomers, for instance. Okay, and let's see what the dominant tautomer is for that. And if we do a search for the dominant tautomer, it will give you the tautomers that are possible for it. And I'm just going to zoom in on this, and let's just see. Now, you notice that this here, with the double bond to the nitrogen, is a structure I drew in. And it's interesting to say that it has calculated that the distribution of that tautomer is 0%. So this is a tautomer that is at 0%. And this is a tautomer that is at 100%, where it prefers to have the nitrogen here, instead of being double bonded with a hydrogen, and the nitrogen in the ring with a double bond. So it's interesting. You can do a tautomer search, and you can see that the way I drew it in was not exactly right. The way I drew it in was not perfectly right. I should not have a carbon-nitrogen exocyclic double bond. I should have had a carbon-nitrogen double bond inside the ring, and one of the ring nitrogens should not have had a hydrogen, and it's the external nitrogen that should have had the hydrogen available. So that's really important. So tautomers are really useful. I could save this. I can right-click in that, and I can save that particular structure, that tautomer. That's one thing we can do. Okay. The other thing we can do, so you can see here, this double bond here was not right. I should have had the double bond over here at this point. That's where the double bond should have been. Okay. Right. Another thing we can do is a conformational search. So in terms of conformation, we can search for conformers, and you can, it's a really powerful search you can do, and that can search for lowest conformations if you like. So when you do a search on that, you can see it's found several conformations. But if I can just highlight, if I can just make this bigger and highlight for you, that you can see that these conformations all seem to be quite close in energy. Can you see that the first conformation has an energy of 49.3 kilocalories per mole? And even conformation 4 at 50.14 kilocalories per mole is not far different. It's not even a kilocalorie different to the lowest energy conformation. But as you draw bigger molecules that have that are very flexible, this might become more and more important because you might, as you draw it, you might draw a conformation that is not great at all. And so this can clean up the way you've drawn it and find the best conformation for it. Okay. So your task is going to be, your task is going to be to construct those 5 molecules in Marvin Sketch or in any way you can. And I'd like you to explore, see whether you can do a conformational search, whether you can find the best conformer for the one that you've done, and see if you can find tautomers for ones where tautomers are possible. And please don't forget to write, to record what you do in your construction of the molecules, because that is going to be the start of your write-up that needs to be handed in on Friday. So today, you need to construct those molecules. There's one final thing that I want you to do after you've constructed molecules. If you've constructed a molecule and you have saved it, what would be interesting is, can you take that molecule and place it on the cluster? And to do so, I'm just going to start from scratch again. To do so, once you've saved it, my apologies. To do so, once you've saved it, you go back to WinSCP. Go back to WinSCP. Don't forget it's carbon. And your username, all in lowercase, and the password I sent you. Okay. And then what you do with that is we need to then find, let me just see if I can look at my documents. There we go. Can you see that that's a molecule I've just drawn and saved? So what I can do is I can take that molecule, I can just drag it across. And now I know that that molecule has been copied to the cluster. Okay. So if I need to do accurate calculations, high quality calculations, I can get the power of a cluster on that molecule solving that. Okay. Are there any questions? Okay. Do you know what you need to do for your
Prof?
Wait, Prof, I do have a question.
Yes, a question. Carry on.
Could you please go over what we are doing again today?
So have a look at that document on the continuous assessment. Mm-hmm. And you'll see there are 5 molecules. Did you all get that document?
Yes.
Honors continuous assessment task. There are 5 molecules. And those need to be drawn in Marvin Sketch. We need to make sure that there are hydrogens attached. We need to clean them in 3D. We maybe need to do a conformational search or search for tautomers. But what's more important is after we constructed them, they need to be saved. And once they've been saved, you can try and see whether you can copy them to the cluster. Okay. Does that make, is that all right?
Yes,
yeah,
thank you.
And what's important is that this task needs to be done by tomorrow, which means that if you get stuck, you need to contact me and I need to help you to get past where you're getting stuck. Or if you can't remember what to do after you've drawn your molecule, drop me an email or speak to your colleagues. What do we do with it? How do we clean it in 3D? Okay.
Okay, Prof, can I make a request?
Yes, you can.
You can also upload this recording so that it can help us when you get stuck.
Absolutely. So what I'm going to do is I'm going to try and upload them to YouTube. So please, it's going to take a little while to upload to YouTube. So please be patient. But certainly after lunch, they will be available on YouTube. Okay.
Another question. You said we should record when we're doing this.
So what I want you to do is, if you can take a picture of what you've done and to write down, start a Word document or an open office document and start writing, recording your exact procedure like an experimental procedure.
Okay.
Okay.
All right, thank you.
Perfect. Any other questions?
Prof, for me, from my side, but when SCP. I don't know. I keep on getting denied access, so I'm not sure if it's from.
So that's probably a problem with the username or password. Can you drop me an email reminding me what your username is? Okay.
Okay.
And you are using lowercase for the username, are you?
Yeah, I followed every step, but it
Okay.
keeps on
Okay.
denying me
So
access.
So this is important. If you're struggling with WinSCP, then PuTTY is certainly not going to work either. So drop me an email and say, I can't get onto WinSCP. This is my username. And maybe what I will do is I'll send you a new password and we can try the new password. Okay.
Okay, thank you.
Yeah. Any other questions? If not, I'm leaving the lecture for today. Please contact me if you run into trouble, because we need to have good quality molecules later on in the project. And so drawing them now is going to be a help. Okay. Please contact me if you have any queries at any stage. Okay.